Adding, subtracting, and multiplying radicals. A common error: be careful when adding or subtracting radicals. You cannot add or subtract the radicands, or the insides. So you can't separate this into two radicals. The square root of 4 plus 9 is not equal to the square root of 4 plus the square root of 9. You can add these numbers together, and this becomes the square root of 13. But that's not equal to the square root of 4 plus the square root of 9, which would be 2 plus 3, which would be 5. Note that adding radicals together before taking square root violates the order of operations. For example, you can't just take the square root of each term here, right? Like the square root of x squared would be x, the square root of 9 would be 3. But you can't do this. If they're under the radical, they are currently trapped. If they're not multiplied together, you have to be very careful. To add or subtract radicals, they must be like terms. Radicals are like terms if they have the same radicands and the same indices. So, square root of 2 and the square root of 2, those are like terms. Square root of 5 and 6 times the square root of 5, like terms. The cube root of 7 and 4 times the cube root of 7, those are like terms. Square root of 5 and the square root of 3, unlike terms, cannot be combined. The square root of 2 and 2, unlike terms. The square root of 10 and the cube root of 10 are also unlike terms. An index, plural indices, indicates what root you're taking. Just like square roots undo squares, cube roots undo cubes, fourth roots undo powers of 4, fifth roots undo powers of 5, etc. This concept will be studied more in depth later in the unit. To add or subtract radicals, only the coefficients of the like terms are combined, just like 3x plus 4x equals 7x. So 6 times the square root of 5 plus 3 times the square root of 5, we add the 6 and the 3, and we get 9 square roots of 5. 5 square roots of 7 minus 4 square roots of 7, 5 minus 4 gives us 1 square root of 7. 10 times the square root of 2 plus 10 times the square root of 3 is already in its most simplified form because the square root of 2 and the square root of 3 are not like terms. Try these. 1 square root of 3 plus another square root of 3 is 2 square roots of 3. Here, they have different index values, therefore they're not like terms. So this one's already simplified. Here, we have a like term there and there. So 4 plus 6 gives us 10 square roots of 3. Then we have this 5 square roots of 2 term that cannot be combined. 3 times the square root of 2 plus 4 times the square root of 2 minus 5 times the square root of 2. These are all like terms, so we combine the coefficients. We add them and subtract them. 3 plus 4 is 7 minus 5 is 2 times the square root of 2. It is the same for expressions containing variables. Simplify the following. All right, we have a square root of x, a square root of x, and another square root of x, so they're all like terms. Combine the coefficients. 2 minus 4 is negative 2, plus 1 is negative 1. So we get negative 1 times the square root of x. Here we have a like term and another like term. This one is unlike. 10 plus 3 is 13 times the square root of p minus 4 times the square root of q. Some irrational radicals will not be like terms, but could be put in simplest radical form. In these cases, simplify, then collect any like terms. Square root of 12 minus the square root of 3. The square root of 12 can be rewritten as 2 times the square root of 3. Now you have like terms. 2 square roots of 3 minus 1 square root of 3 is 1 square root of 3. Over here we can rewrite the square root of 8 as 2 times the square root of 2, which is like terms with 3 times the square root of 2. Over here we have the square root of 24, which can be rewritten as 10 times the square root of 6, which is not a like term. So we're going to add these coefficients and we get 5 times the square root of 2 minus 10 times the square root of 6. Multiplying radicals involves applying the properties of roots and simplifying the result when possible. Multiply the radicands, the numbers under the radical. The square root of a times the square root of b is equal to the square root of a times b. For example, the square root of 3 times the square root of 2 is equal to the square root of 6. Multiply these expressions. Multiply these expressions. Negative 6 times the square root of 7 times the square root of 10. Negative 6 times the coefficient of 1 is negative 6. The square root of 7 times the square root of 10 is the square root of 70. 5 times 4 equals 20 times the square root of 3. So 20 times the square root of 3. Multiply these expressions. All right, so 5 times 4 gives us 20. 2 times 6 gives us 12. But the square root of 12 can be further simplified to 4 times 3. 4 is 2 squared, so one of those 2's goes out front, and the 20 becomes a 40, leaving behind the square root of 3. We have 10 times 1 is 10. 7 times 7 is 49, but the square root of 49 is 7. So therefore 7 times 10 gives us 70. Negative 3 times 4 gives us negative 12 out front. 10 times 15 gives us 150 under the radical, which can be further simplified to negative 60 times the square root of 6.